All right, welcome to your first class with me. Last time you saw this face, I was walking through a PowerPoint slideshow to talk to you guys about who I'm all about and what I do and what I'm expecting of you this year. So today, it's Tuesday. We're stepping into our very first actual Algebra 2 content. And really, today we're just doing some review. In fact, most of this week will just be review. We're going to be looking at expressions, equations, simplifying some things, solving some things. We're going to take it nice and slow and ease you back into things after the summer. So today we're just starting with simplifying expressions, and we need to talk about a few specific definitions before we dive into the actual content. First, we want to look at what a term is. What is a term? A term is what I'm going to describe as a collection of variables and coefficients. So variables and coefficients. Okay. And there's going to be several of these that we're going to see on the next page. I'll try to point out what each one is to give you some clear examples of what I mean when I say term. Variables are the letters that we use to represent values, that maybe we don't know what the value is, or maybe we have something to substitute in. And coefficients are the numbers, like 1, 2, 3, 4, and so on. Coefficients can be positive, they can be negative, and a term is going to be any grouping of those that are together, okay? An expression, then, is going to be the bigger form of that. If I've got one term, that might be part of an expression, or it might be the entire expression itself. I'll point that out as we're going as well. But I'm going to say that it's all terms that make a single unit. Okay, so I can look at a set of variables and coefficients, and they're separated by addition and subtraction, stuff like that. I might be able to describe that as an expression. And then what makes an equation? Typically an equation is two expressions separated by an equal sign. Give that by and an equal sign. Okay, so two expressions side by side, separated with that equal sign in the middle. All right, got that. Let's look at an example. We won't be dealing with equations today. We're going to come back to that probably Thursday, but we are going to go a little bit deeper into terms and expressions. Here is my first example right here. Okay. Now I've got this first expression, that's 3x plus 7y minus 2x plus 3y minus 4 plus 4x. How many terms do you think are in this expression? If you said 6, you got it right. There's 6 different terms in this expression, at least as I have it started here. Okay, we got this term here with the coefficient 3 and the variable x. This one here, coefficient 7, variable y. The negative 2 and the x here, the 3 and y, the negative 4, and then the negative 4x. And then you'll notice I have it simplified down here. I've got all of those terms added together and then reduced down as far as I can get it in this expression down below. And you notice that I've got these color-coded. I've got this one red, and this one red. These two are blue, and then this guy right here is orange. I did that very intentionally because you'll notice the 3x, the negative 2x, and the 4x all have one thing in common. They all have an x, which means in order to simplify those, I can add their coefficients together. So I can say 3 minus 2 minus 4. 3 minus 2 minus 4 gives me this negative 5 down below. So let me grab my red. This negative 5 corresponds to the 3x, negative 2x, and negative 4x I started with up above. You'll notice also that I've got the blue positive 7y and the positive 3y. When I added those together, we got a positive 10y, right? 7 plus 3. They have the same sign, so we add the values together, we get that 10y. And then we had just the one negative 4. That was all I had as far as terms that were just a single coefficient. There are no variables on that term, so I just left it alone. I copied it straight down. And this is as simplified as this expression can be. We cannot combine any other terms together. The negative 5x and the positive 10y don't mix because they don't have the exact same thing. That brings me to a question. How do I know what can be simplified and what can't? Let's look at a few of these expressions here, and let's talk about each one individually. I'm going to switch to my red, and I'm going to look at each set of terms, each expression. So this group here, group A, says 2a squared b plus 4ab squared minus ab. What do you think? Can this expression be simplified? Yes or no? Okay, if you said no, you would be correct, because here I've got an a squared, here I've got a b squared, and here I've got an ab. Now, they do have the exact same letter every single time. There's an a and a b in every single one of these terms. However, this first term has two a's. This second term has two b's. That's what these exponents are telling me. And then this third term only has one of each. And because of that, because the variables don't match perfectly, we aren't allowed to simplify by adding these terms together. We can't add those coefficients. We're not allowed to do that. Mathematically, if the variable counts don't match, we're not allowed to add terms. Okay? What about letter B? 74fx plus 16fx minus 30fx. What do you think? Can I combine those terms? All right. If you said yes this time, then you were correct, because 74fx, 16fx, and negative 30fx, even though the coefficients don't match, that's not a problem. This time the variables do. I've got a single f and a single x in every single one of my terms. All three of those can actually be added together, and that's awesome. So 74fx, 16fx minus 30fx, we could add that together and get a reduced value, or a simplified value rather, not reduced. Reduced is a different thing. How about expression C? If I have 3/4 t minus 2/3 t, can that be simplified? Yes or no? Think about it. All right, if you said yes, then you got this one correct. Because here, once again, even though the variables, the variables matched this time, even though the denominators of those fractions are different, we are allowed to get a common denominator. We're allowed to add those coefficients together, or I guess in this case subtract. So the thing we're looking at, the thing we're focusing on when we're trying to answer this question of yes or no, can these be simplified, is do the variables match? Do we have the same exponents? Do we have the same values? Things like that. The coefficients don't really matter as much. We might have to do some finagling to get this to add together or subtract, because fractions are weird, and I admit that, but we are able to do it, so that's super awesome. What about letter D? What do you guys think? Can we combine these terms? All right. If you said no, you got that one correct, because this time, even though the letters are the same, they're in the wrong spots. You see what I'm saying? the first term has an A in the numerator and a B in the denominator, and the second term has a B in the numerator and an A in the denominator. And while we could get a common denominator, we would not be able to combine these expressions because the variables wouldn't match up. We would not have the exact same number of A's and the exact same number of B's in the correct spots for either of those fractions. It wouldn't play nice, it wouldn't combine. We're not able to simplify those expressions in any meaningful way. We're going to take a quick break here for something else. Okay, one thing that I'm going to try to do every day as part of the video that you watch for the day is I'm going to try to break it up into 3 distinct portions. Portion 1 you've already seen. It's going to be the introductory lesson. Portion 3 is going to be more examples, maybe some more variety in ways in which the principles in section 1 get used. It's going to be just ways to expand and prepare you for the assignment for the day. Section 2, though, is going to be the section that I'm going to call Today is Awesome, TIA for short. And it's not going to be something that you're graded on. It's not going to be something that you even have to watch. In fact, I'll, if I'm able to, I'll try to give you timestamps for where it starts and where it ends, so that you can skip past it if you want to. This part is entirely optional. It's just something that was free for you if you wanted it. I wanted to kind of break up the monotony of my lecture and make something that might be a little more interesting to you. A lot of this is going to be very off the cuff. I've got a few ideas for what this is going to look like, but I definitely want to hear from you guys. I want to hear what you think about my ideas and about how this goes. If it were up to me, it would probably just be a lot of gaming content, but I know not everybody is interested in that kind of thing. So I do want to get your feedback. So do let me know what you think, and I'll give you a few different ways to do that if you wish. But for our very first one, I went with what was easy for me, and I kind of alluded to it a little bit in the video from yesterday, but I wanted to start the very first Today is Awesome with my favorite games, at least the top 5 that I like to play right now. And we'll get started with number 5. Number 5 is an old classic, Chrono Trigger. Chrono Trigger is a Super Nintendo game released in the 90s. Art style is similar to lots of old anime. The main character, that red-haired guy, looks probably a lot like Goku from the Dragon Ball series. Because the guy who drew all of the art for Chrono Trigger also drew the art for Dragon Ball. None of that matters. It is just part of the old school charm that this game has. Okay. So that's Chrono Trigger. The story concept is really interesting, and the characters are all very fun. Hopefully you're seeing a little bit of gameplay of it now, if I manage to pull that off as well. Okay, number 4. Number 4, my next favorite would be Super Mario Odyssey. This one's a little more modern. Every time I got on my Switch to play this game, I would just get this big smile on my face, because running around as Mario in this really, really cool world always felt great. This is probably my favorite iteration of Mario. He controls beautifully. Running, jumping, slipping, sliding, dodging, rolling, everything has never felt so good, and this game just really, really gives you that freedom to explore and collect all kinds of awesome rewards. You can dress Mario up however you want. It's just a good time. I love this game so very much. Number 3, very quickly, is Risk of Rain 2. I love this game. It is brand new. In fact, the 1.0 update released less than a month ago. And I've even gotten into modding this game and playing around with different mods and changing the way the game works. This game is weird, but it's got a very unique aesthetic and a very, very unique concept, where you start as one of 10 different characters, and you have the option to play the game for as long as you're able to stay alive. There are ways to end a run of Risk of Rain 2 early, but there are ways to keep it going forever if you were able to survive that long. The game infinitely scales, all the enemies get infinitely stronger, and so does your character. And there's just so much that can be done with that concept, and it's such a well-delivered and well-executed game. I really enjoy it. It's a good time. I've played it online with friends multiple times, and it continues to be a good time every time I open it again. Number 2 is League of Legends. League of Legends is a game I've been playing for about 8 years now. It's kind of a hard one to describe, but it is the best time I have had with friends, I think, with any other game I have played. Scratches that fun, hang out with friends kind of itch, and also scratches a hardcore competitive itch, in case you're into that kind of thing. This game is wonderful. Not easy to learn, but there's a lot of space for those who put in the time to master it and really get good. So definitely a good game. Probably not for everybody though. My number 1 game though, and I mentioned it in my slideshow yesterday, is Celeste. I love this game. The pixel art, the platformer gameplay, the character narrative. It's such a special game, and I recommend it to anybody who's interested in games. It's easily my number 1 game. Such a fantastic time. Hopefully you're seeing a little bit more of that gameplay as well. I'm really hoping I can get some of this recorded and put in here as well, so you can see some of these. But that's my top 5 games. That's number 1 right there. Just as a closer here, submit your suggestions. Remember, I want this to be something that you guys give me feedback on. I don't want to just make gaming stuff and toss it in here. I want to maybe do some reaction videos, maybe look at some memes or some subreddits. I want to look at different things you guys send me. And of course, you can send me anything that you're interested in, anything you want me to react to. I can't guarantee that I'll look at everything you send me, but I've got about 120, 130 of you guys in all 5 of my classes. So anything you send me is fair game, provided it's something that would be okay at school, would be allowed here. So make suggestions through email, that email address there, or put it in the comments down below. Thank you, and I look forward to hearing from you guys. Back to the lesson. Alright, welcome back. Hope you enjoyed that quick little break. We're going to do 2 quick problems so that you guys have an idea of how to solve the problems that you'll have on your homework tonight. And we're going to start with this first expression. It's got 2xy plus 3yx plus 7xy. So we've seen already an example of how to simplify. We've walked through the process of figuring out how do we know can it be simplified. We look at this expression, we see, okay, every single term has an xy. It's worth noting that even though this says yx, it can also be added to the other 2 expressions. Order doesn't really matter. The thing that matters is the number of x's and the number of y's. So even though the first term and the last term say xy, and then that middle term says yx, we're still able to combine everything because each term has one x and one y. We're still able to combine them. So if I just do what I've been doing, I add the coefficients together. 2 plus 3 plus 7. 2 plus 3 is 5, plus 7 makes 12. This ends up being 12xy, and I'm allowed to rearrange those variables however I want. I choose to go in alphabetical order, x, y. I feel like that makes the most sense, and that's simplified. That's as simple as it gets for that one. Let's look at the second one. This one's going to be a little bit different, and hopefully we'll answer a couple of the questions that maybe have come to mind as I've been working through this. What if you have something that looks a little bit more like this? This is certainly more complicated. There's more going on, more moving parts. First of all, we've got the same problem we saw last time, where some things are a little out of order. We've got the negative 10a squared b squared c minus 5a squared c b squared plus 10ac. Once again, we've got the same number of a's. We've got the same number of b's. And then we've got the same number of c's, which means these two terms can be added, or in this case subtracted, but this one cannot be, right? So what happens if I've got two terms that can be combined and a third term that doesn't really fit? Well, we combine the terms we can, and we just copy down the term we can't. So I'm just going to move this one straight down, plus 10ac. Can't be combined with anything, so we leave it alone. We're just going to copy it. What about the other one, though? The other two terms? Well, order doesn't matter, only the number of variables, and this time the number of variables matches. So we're allowed to do our subtraction. Negative 10 minus 5, since they both have the negative sign, we're allowed to add those values together and then keep that sign. So negative 10 minus 5 gives me a negative 15, and then I'm just going to choose to rearrange them so that they're all following alphabetical order. A squared, b squared, and c. And that, my friends, is simplified. All right? Good luck on your homework tonight. If you have any questions, be sure to let me know in the comments down below, or send me an email. That's always a welcome thing. I'm always looking forward to hearing from you guys and seeing what you're struggling with, what you need help with. If you need to set up a time with me, definitely email me and ask for some more tutoring help if you need that. All right, that should be it. Thank you.